Hello everyone, welcome back to channel again. So in this video, let's solve one problem from supernode analysis. So supernode analysis is nothing but if there is a voltage source between two major nodes is nothing but supernode. So it's nothing but if there is a voltage source between two major nodes is nothing but that type of a node you can call this as supernode. For example, you can observe in this particular problem now. So here the super node is nothing but you can see major nodes. How many major nodes are there? One, two, three major nodes, one reference node. That is nothing but V reference. The value of this is 0. So now the voltage source which is between two major nodes. Major node is nothing but 1 and 3. So that you can call this V1 and V3 are the super nodes with respect to 8 volts. So that you can write the equations of this V1 and V3. So how will write with respect to 1 V1 minus V3 apply KVL like this at this direction. So V1 minus V3 and the second polarity have right that is minus 8 that is equals to 0. So that V1 minus V3 equals to 8. Okay. The first supernode minus second supernode with respect to minus 8 volts. So that V1 minus V3 and second polarity is minus. So like that you have to write the nodal equation. So now without wasting time, let's go to the problem. Rest of the methodology is same. Okay. So now let us consider this problem. Refer the electric circuit, find VA. They asked you to find VA. So you need to find the value of VA. So VA is nothing but this. So that is nothing but this node voltage. So first mark the node voltages. There is a V1, V2, V3 and reference node. Okay. Then give the direction of current with respect of that. That is nothing but I1 which is leaving from here and I2 is also leaving. And the value of V2 we already know. The value of V2 is 12 volts from the circuit itself. So from V3, the V3 is nothing but VA. You need to find this value. V3 is nothing but VA. Again, I am considering here I3 is flowing here and I4 is flowing here. So from supernode, we'll get one equation. From supernode. So first you should know which is supernode. The voltage source which is connected between V1 and V3. So that supernodes are V1 and V3. So from this we need to write V1 minus, suppose if you're assuming current which is flowing from here like this, say that unknown current, so that V1 tail end voltage minus arrow end voltage, then you are tracing from V1 to V3, so while tracing second polarity that is negative, minus 8 equals to 0, so that you can write V1 minus V3 equals to 8. Suppose if it is having a minus and plus polarity with respect to 8 volts, like this in between V1 and V3, like this. Suppose if it is like this, in that case, if the current direction is like this, you can write V1 minus V3 in the second polarity is plus 8 equals to 0. So that you can write V1 minus V3 equals to minus 8. Just for example, this is the example. Okay. So now from super node, you'll get one equation V1 minus V3 equals to 8. This is equation number 1. So now to solve this problem from super node, so you should know the condition, the algebraic sum of from super node, the algebraic sum of currents at super node, currents at super node is 0. So at super nodes, V1 and V3 are the super nodes. So observe now at V1, at node V1, observe the currents. I1 is leaving, so that minus I1 minus I2. Similarly, at V2 node, at V3 node, I3 is also leaving, I4 is also leaving, so that minus I3 and minus I4. So that from from super node you're writing the algebraic sum of these currents at super nodes V1 and V3 equals to 0. That's nothing but minus I1 minus I2 algebraic sum. You need to add plus into minus minus, so that minus I3 minus into plus minus again minus I4 equals to 0. So that is nothing but minus I1 minus I2 minus I1 minus I2 plus minus I3 minus I4 equals to 0. Algebraic sum of currents at supernode is 0. So you can also rewrite here I1 plus I2 plus I3 plus I4 equals to 0. So now you write what is I1, what is I2, I3, I4. I1 how will write now? I1 is nothing but V1 divided by 500. Similarly, how will write V1 divided by 500 is nothing but 1 divided by 500. That is nothing but 2 milli. 2 milli is nothing but 0.002. 0.002 V1. Similarly, how will write I2? So I2 you can see tail end voltage minus arm end voltage. That is nothing but V1 minus V2. You already know that is 12. V1 minus 12 divided by 125. So you can also rewrite like this. 1 by 125 is nothing but 0.008 V1 minus 12 divided by 125. 0.096. This is I2. Similarly, I3, you can observe I3 is nothing but V3 minus V2. Tail end voltage minus arm end voltage. V3 minus V2 is nothing but 12 again. V3 minus 12 divided by 250. So 1 divided by 250 is nothing but 0.004, or this 4 milli. 0.004 V3 minus 12 divided by 250. 0.048. This is I3. Similarly, I4 how will write? V3 minus 0 divided by 500. That is nothing but V3. V3 is nothing but VA, that only we need to find. V3 divided by 500. So 1 divided by 500 is nothing but 0.002 V1 V3. 0.002 V3. This is I4. Now we substitute all the values. So you can get 0.002 V1 I2 plus 0.008 V1 minus 0.096 I3 is nothing but plus 0.004 V3 minus 0.0048. Similarly, I4 is nothing but plus 0.002 V3 equals to 0. So V1 term we can observe only 2. 0.002 plus 0.008. Nothing but 0.01. 0.01 V1. V2 you can observe, V2 is not there. V2 is nothing but 12, you already know. V3 you observe. So 0.004 plus 0.002. That's nothing but 0.006, 0.006 plus 0.006 V3 minus 0.096 plus 0, minus 0.048. Looking at 0.144 minus 0.144 equals to 0. So you can rewrite this 0.01 V1 plus 0.006 V3 equals to 0.144. This is equation number 2. Now you solve equation 1 and 2. You'll get the value of V1 and V3. So that V3 is nothing but VA. So keep your calculator in equation mode, two unknowns, 1 minus 1, 8. So here 0.01, 0.006, 0.144. So you can get V1 is 12 volts, but we want V3. That is nothing but VA. So I'll write it here by solving with the help of solve equation 1 and 2. You can get V1 equals 12 volts and V3, that is nothing but VA equals 4 volts, and this is the answer. So observe that clearly, the algebraic sum of currents at supernodes equals to 0. So at supernode are V1 and V3. So ಇದರಲ್ಲಿ supernode V1 ಮತ್ತೆ V3 ಯಾಕಂದ್ರೆ ಮೇಜರ್ ನೋಡ್ಸ್ ಮಧ್ಯೆ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿರೋದಕ್ಕೆ ಸೂಪರ್ ನೋಡ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಸೂಪರ್ ನೋಡ್ ಇಕ್ವೇಶನ್ ಬರೆಯುವಾಗ V1 minus V3, I am assuming current which is flowing from V1 ಅಂತ assume ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. I don't know the value of current, so that just giving arrow mark. V1 minus V3 minus 8 volt. So as per KVL, minus 8. V1 minus V3 minus 8 equals to 0. So that can write V1 minus V3 equals to 8. So ಅಲ್ಲಿಂದ ಒಂದು equation ಬರುತ್ತೆ. So node 1, that's nothing but V1 node ಅಲ್ಲಿ currents ನೋಡಿ I1 ಲೀವ್ ಆಗ್ತಾ ಇದೆ, I2 ಲೀವ್ ಆಗ್ತಾ ಇದೆ. So that minus I1 minus I2 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. V3 node ಅಲ್ಲಿ I3 I4 ಲೀವ್ ಆಗ್ತಾ ಇದೆ, ಅದಕ್ಕೆ minus I3 minus I4 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ಕರೆಂಟ್ಸ್ V1 ಮತ್ತೆ V3 ನೋಡ್ಸ್ ಅಲ್ಲಿರೋ ಕರೆಂಟ್ಸ್ ನ ಎರಡನ್ನು ಆಡ್ ಮಾಡಿ ಈಕ್ವಲ್ಸ್ ಟು 0 ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಅದಕ್ಕೆ minus I1 minus I2 minus I3 minus I4 equals to 0 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. I am sending everything to right side so that I1 I2 I3 I4. ಅದಾದ್ಮೇಲೆ I1 I2 I3 I4 equations ನ ಸರ್ಕ್ಯೂಟ್ ನೋಡ್ಕೊಂಡು ಬರ್ಕೊಂಡಿದ್ದೀರಾ in the form of V by R. So that tail end voltage minus arrow end voltage divided by resistor. So ಅದಕ್ಕೆ I1 is nothing but tail end voltage V1, arrow end voltage V reference. So value of V reference is 0. ಅದಕ್ಕೆ V1 divided by 500. So this is about supernode. So very simple to understand. If you're having any doubts regarding this, feel free to write in the comment box. And also, if you like this video, kindly subscribe and share maximum. Thank you so much. Have a nice